Part 3 of the book presents contemporary physics and its philosophy and metaphysics. Contemporary physics include 1. Relativistic physics. 2. Quantum physics, which corresponds to the first quantum revolution. It includes quantum mechanics, quantum field theory and the Standard Model, quantum vacuum. 3. Quantum gravity. 4. Quantum information and computing, which corresponds to the second quantum revolution. This revolution has an impact on quantum mechanics, quantum field theory and quantum gravity. Note that this third part of the book is presented very briefly in this episode and the next. See the book for details. The key point to remember is that contemporary physics has sought to zoom ever deeper to uncover the nature of matter, energy, space, and time, etc. To zoom deeper, quantum mechanics has been developed further, alongside with special relativity, leading to quantum field theory and quantum vacuum. Then to zoom even deeper, for instance to know the nature of space-time, they lead, together with general relativity, to quantum gravity. Quantum information and computing shed light on quantum mechanics, quantum field theory and quantum gravity. The more physics zoom in, the more it discovers that matter-substance, material objects, elementary particles of matter, is a mirage, an illusion, and that materialism is a great error. In its introduction of quantum mechanics, the book presents the main points of this field. For instance, the discrete and granular nature of quantum mechanics, uncertainty or indeterminacy principle, possibility and superposition of states, possibility, or potentiality, is presented as superposition of states. Wave-particle duality, wave function, collapse of the wave function, and the double-slit experiment. Measurement problem. Entanglement, non-separability, and non-locality, etc. Maybe the most fundamental aspect of quantum physics is neither the uncertainty principle, nor superposition, nor the wave function, nor wave-particle duality, nor measurement, nor even entanglement, but the fact that quanta are characterized by possibilities and the transition from the possible to the actual, following an act of choice and thus the creation and processing of information. Possibility is fundamental to quantum mechanics and to information theory and information processing system, where information refers primarily to an act of choice of a possibility from a set of possibilities. So, we can ask, are quanta dynamic information processing systems? So, as a conclusion of a philosophical study of contemporary physics, we can say that quantum mechanics reveals that the reality of matter is energy, which refers to activity and action, and information and possibility, which refers to information creation and processing. After the introduction of contemporary physics, the book presents several metaphysical interpretations of contemporary physics. First, it differentiates between realist, anti-realist, agnostic, and instrumentalist. Then, it presents various interpretations. Copenhagen interpretation, pilot wave interpretation, spontaneous collapse of the wave function interpretation, many worlds or magical realism interpretation, quantum Bayesianism or QBism interpretation, relational-structural interpretation, relational quantum theory, possibility-potentiality-based interpretation, event and process-based interpretation, information processing-based interpretation, which constitutes the main focus of the book, chapters 4, 5, and 6. So let us focus on the informational-processual interpretation of contemporary physics and the world. James Gleick noted rightly that increasingly, physicists and information theorists are becoming one and the same. The fourth chapter of the book introduces the informational-processual interpretation of contemporary physics. It discusses the nature of information, making an emphasis on the definition of information as the act of choice, and the place of information in the world. It introduces the information processing paradigm and its implications, and also the digital ontology metaphysics and its critique. As noted in this diagram, there are some direct and indirect relations between the previous interpretations and the informational-processual interpretation. The informational-processual interpretation of contemporary physics can be considered according to the epistemological perspective and the ontological perspective. According to the epistemological perspective of the informational-processual interpretation, quantum mechanics is about information. According to the ontological perspective of the informational-processual interpretation, the world is made of information. About the ontological perspective of the informational-processual interpretation, there are 4 theses regarding the place and ontological role of information at the physical level. Information has no ontological role. Information emerges only with biological life. Information and energy are the 2 primary realities. Information is the sole primary reality. The nature of information. Information, like energy, takes many forms, has many meanings, and is found in various fields and applications, viewed from different perspectives. Different approaches or perspectives, semantic/philosophical/epistemological, mathematical, systemic, dialectical logic, etc. Different theories of information. Statistical theory of information, semantic theory of information, algorithmic theory of information, pragmatic theory of information, and theory of information dynamics. 3 classic definitions of information. To inform in the sense of instructing, communicating, and conveying a description of a situation, a fact, a phenomenon, or the state of a system. To inform in the sense of giving form, structure, or organization to an entity, action, process, or system. Information as the act of choosing one possibility from a set of possibilities. Possibility is present at all levels of existence. This is also the case with information. The universality of the definition of information refers to its omnipresence in the world, a set of possibilities, regardless of what those possibilities are. The information processing paradigm and its consequences. The information processing paradigm is one of the great discoveries of the modern era. It has had a profound impact on, and has shaped, technology, thought, culture and the lives of individuals and societies. Contemporary humans are increasingly recognizing the central role of information in their lives and at every level of existence. They recognize the universality of the information processing paradigm, which applies at every level of existence, from cosmology and physics to psychology and sociology. The world according to the information processing paradigm. Who would have suspected or even imagined that this soft, static and inert matter that is the brain actually corresponds to a hypercomplex dynamic information processing system? Who would have suspected or even imagined that this microscopic matter, known as the cell, is in fact a hypercomplex dynamic information processing system? The same is true of every organ and every living organism. What about the physical world, atoms, quanta, quantum fields, the quantum vacuum, space-time, etc.? Could the atom also be a complex dynamic information processing system? Could the quantum vacuum also be a complex dynamic information processing system? The answer is surprising, yes. As early as the 1960s and 1970s, researchers began to view the physical world as a computer or a dynamic information processing system. But it was particularly from the 1980s and 1990s onwards, with the onset of the second quantum revolution, that the process-based informational interpretation of the physical realm began to gain increasing acceptance. Not only the atom, but the quanta that make up atoms, quantum fields, and the quantum vacuum also appear to be dynamic information processing systems. Unbelievable but true. 5. Early development of the informational-processual (IP) interpretation, 1980s and 1990s. The book considers different works in this period, related to the informational-processual interpretation. The IP interpretation by David Bohm and his colleagues, which include concepts like quantum potential, holistic and dynamic implicate order, or holomovement, explicit order, etc. IP interpretation by Carl Friedrich von Weizsäcker and his colleagues, that is similar to qubit. IP interpretation by John Wheeler and his colleagues, it from bit. IP interpretation by Klaus Hafner and his colleagues. The evolution of the world is conceived as an evolution of natural dynamic information processing systems. Relation between information dynamics and dynamic systems. 6. Further development of the information-processual (IP) interpretation, from the 2000s onwards. The book considers the development of the information-processual (IP) interpretation in the recent period, from the 2000s onwards, and the impact of this development on different aspects of contemporary physics. IP interpretation of the second quantum revolution. IP interpretation of the quantum level. IP interpretation of quantum field theory. IP interpretation of the quantum vacuum. Quantum vacuum, condensed matter physics and quantum information. Quantum vacuum as a dynamic cosmic memory. IP interpretation of quantum gravity. IP interpretation of the emergence of spacetime. Recent developments in the IP